Welcome to the chemistry class. In the previous classes, we studied how to write the subshell electronic configuration of elements with atomic number 1 to 30. Today we are going to study about the block and group of various elements. The block to which the element belongs will be the same as the subshell to which the last electron is added. In lithium, the last electron is entered in 2s subshell, so the block is S. In magnesium, the last electron is added in 3s subshell, so the block is S. In nitrogen, the last electron is entered in 2p subshell, so the block is P. In scandium, the last electron is entered in 3d subshell, so the block is D. From this table, we can understand there are various blocks, so they are S, P and D. Next, we are going to study the group number of various elements. First, we will study about the group number of S block elements. For S block elements, the number of electrons in the outermost S subshell will be the group number. Lithium subshell electronic configuration is 1s2, 2s1. Number of electrons present in the last subshell is 1. So the group number 1. In sodium, last electron is entered in 3s subshell. Number of electrons is 1, so the group number 1. In magnesium and calcium, number of electrons present in the last subshell are 2, so the group number is 2. Next, we will study about the group number of P block elements. P block starts in the periodic table after 12 groups. So, group number of P block elements can be found by adding 12 to the number of P electrons. In boron, atomic number 5, so the subshell electronic configuration is 1s2, 2s2, 2p1. Number of P electrons is 1, so the group number is number of electrons in P subshell plus adding 12 get 13. In nitrogen, group number 15. In neon, number of P electrons is 6, so group number 18. Group number of P block elements are from group 13 to 18. Now we are looking the group number of D block elements. In the last class, we studied the subshell electronic configuration of elements with atomic number 21 to 30. Now I write only the outermost subshell electronic configuration. For scandium, the outermost subshell electronic configuration is 3d1, 4s2. The D block elements group number is number of electrons in D subshell and number of electrons in S subshell. That is, by adding number of electrons in 3d subshell and 4s subshell, that is 1 plus 2, the group number of scandium is 3. Vanadium, group number 5. Nickel, group number 10. Now we studied the group number of S block, P block and D block elements. From the periodic table, we can understand the group and block of various elements. The period number is same as the shell number of the outermost shell in the subshell electronic configuration. First write the subshell electronic configuration. Then find the shell number of the outermost shell. This is the period number. Example, for finding the period number of beryllium, first write its subshell electronic configuration. That is 1s2, 2s2. The shell number of outermost subshell is 2. Therefore, the period is 2. The subshell electronic configuration of scandium is 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, 4s2. Its outermost subshell is 4. So the period is 4. Note that in scandium, last electron is filled in 3d subshell, but the outermost subshell is 4s. Therefore, the period is 4. Now we can find the period, group and block of these elements by writing the subshell electronic configuration. Let's check the answers. Elements of group 18 in the periodic table are inert gases or noble gases. They are helium, neon, argon, krypton, xenon, radon. The subshell electronic configuration of helium, neon, argon, etc. are given in the table. The subshell electronic configuration of helium is 1s2. Neon is 1s2, 2s2, 2p6. Argon 1s2, 2s2, 2p6, 3s2, 3p6. In this chapter, we have to study only about the elements of atomic number 1 to 30. Therefore, only subshell electronic configuration of helium, neon and argon are needed now. Next, we are going to study how to write the subshell electronic configuration based on noble gases or inert gases. Let's check the subshell electronic configuration of lithium, that is 1s2, 2s1. The inert gas comes before lithium is helium. So, we can write that the subshell electronic configuration based on noble gas is helium 2s1. Note that you have to write helium He in a square bracket. Likewise, the subshell electronic configuration of chlorine is 1s2, 2s2, 2p6, 3s1. The inert gas comes before chlorine is neon. So, its configuration can be written as Ne 3s2, 3p5. Note that put neon in the square bracket. Likewise, the subshell electronic configuration of scandium is 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, 4s2. The inert gas that comes before scandium is argon. So we can write as Ar 3d1, 4s2. Put Ar in the square bracket. In this way, you can write the subshell electronic configuration based on noble gas of elements with atomic number 3 to 30. Okay, thank you.